Hello class, my name is Melanie Sun. In this presentation, I'll be covering the key concepts of functional and non-functional software testing and highlighting their differences. First, let's define what functional testing is. Functional testing is a type of software testing that verifies that each feature of the software functions as expected based on defined user requirements. Functional testing focuses on what the software does and examines the specific outcomes in response to various inputs. For each component, we have expected outputs that can be compared with actual outputs to validate correctness. The main goal of functional testing is to ensure that the software operates correctly from an end-user perspective. This involves creating test cases that simulate typical user actions to verify that all features work as specified. For example, functional test cases can validate data entries to see if they are correctly updated, saved, or retrieved in a database within an application. This may involve checking that a user can successfully submit a form and that the submitted data is accurately recorded and retrievable. Additionally, functional testing could verify if interactive elements in a user interface respond appropriately. This might involve testing buttons or dropdowns to ensure they produce the correct action. A submit button should send form data to the server, while a cancel button should clear out a form. Access control mechanisms for user authentication can also be verified with functional testing. We would check that users with the correct credentials can sign in, while those with incorrect details are denied access. In summary, functional testing ensures that the software delivers its intended features and answers the question of, does this software do what it's supposed to do? Now, let's discuss how non-functional testing differs. Non-functional testing is a type of software testing that evaluates how well a system performs under different circumstances. While functional testing focuses on what the software does, by verifying specific features and behaviors, non-functional tests are about the qualities of the software that shape the user experience. The main goal of non-functional software testing is to ensure that the software is reliable and efficient, enhancing user satisfaction and confidence in the product. Non-functional testing addresses questions like, can this software be breached, which is a security concern, or can this system be easy to operate, which touches on software usability. By exploring these factors, non-functional testing helps developers identify potential issues that could impact the software's appeal or functionality in real-world conditions. After covering the main differences between functional and non-functional testing, let's take a moment to see if you can identify what these software testing techniques are classified as. Please pause the video and see if you can sort these accordingly. I will reveal the correct answer in 10 seconds. Alright, so these are what the software testing techniques are actually classified as. We have 4 examples of functional testing techniques: unit testing, integration testing, smoke testing, and regression testing. These testing techniques all deal with verifying software output. Examples for non-functional testing techniques are usability testing, security validation, and performance assessment. These testing techniques examine the quality of the software. No worries if you answered any of these incorrectly. We will cover each testing technique in more detail in the following slides. Let's go ahead and dive into the functional testing techniques. Unit testing is a valuable approach for testing individual components in isolation. It can test against a method or function and verify each block of code produces an output that matches an expected result. Incorrect outputs can help software developers detect errors and debug their code during the development process until it produces the correct results. One of the most popular testing frameworks for unit testing in Java is JUnit. It provides a suite of assertion methods that validate test results. An example would be assert equals, which allows developers to compare outputs and fail a test if the values do not match. Integration testing deals with multiple software components and ensures that they work correctly when combined. The primary goal here is to identify any issues when different parts of the software interact. For example, integration testing can reveal data transfer failure by checking if data is sent from one component and received in the wrong format by another component. This can help developers catch issues early and find errors that they might not be able to catch in unit tests, thus reducing the introduction of bugs into the overall system. Smoke testing involves testing the essential functions of an application after a new build. It is used to verify that there are no major issues with a software build, as the preliminary checks ensure that features are operating as expected. By rejecting builds with significant issues, this saves time and resources. Failures result in further development until the software is in a stable state to be tested further. Regression testing is typically performed when fixing bugs, after adding a new system feature, or before a software release. It makes sure that new updates do not break the existing code baseline, and there are different types of regression testing. In the complete, or also referred to as retest all technique, the test suite is executed again in its entirety, which can be thorough but time-consuming. Selective regression testing deals with only a subset of test cases that would be affected by the software updates. And for test case prioritization, high priority tests are determined and executed to identify issues quicker. Now, we will shift gears and go over the non-functional testing techniques. We will talk about 3 non-functional testing techniques side by side. Usability testing focuses on how intuitive and user-friendly the software is. It can help assess the user experience and the ability for users to accomplish their tasks. Testers can observe real users interact with the software and identify potential issues, such as unclear instructions or a steep learning curve. This type of testing improves the overall accessibility and design of the application. Security validation is critical for identifying and addressing vulnerabilities in the software. It aims to protect the system from unauthorized access or data breaches, and also prevents hackers from exploiting any parts of the software. This builds user trust and ensures that sensitive information is handled securely. And last but not least, performance assessment evaluates how the system behaves under different workloads. This involves load testing, which determines how software performs under expected user traffic, and stress testing, which identifies the software's limits. By identifying performance bottlenecks, this can tackle software inefficiencies and avoid user frustration. All of these techniques are critical for delivering a software product that meets high quality standards. So to recap, what were the important things we talked about? You now know what makes up the difference between functional and non-functional testing, and examples of both. Remember, functional testing addresses what the software can do, whereas non-functional testing is concerned with how the system behaves. Together, these 2 testing techniques cover all the bases to make sure that the software is robust and works successfully. If you want to learn more about how functional and non-functional testing is applied in the industry, here are some testing tools that perform the various tests we discussed earlier. Thank you for taking the time to watch this video, and I hope this enriched your knowledge on software testing techniques.